we're going to cover it. Okay, here we go. Guys, look at these. So here's the answers. 1 is acute equilateral, 2 acute scalene, 3 obtuse isosceles, 7 obtuse scalene, 8 acute equilateral, 9 right isosceles. Here's my question. Here's my question to you guys that I want you to answer. I'm going to pose 3 hypothetical questions to you guys, and then I want you to, just 3 questions, and then I want you to answer them together. First, how do the angles relate when we know that it's an isosceles triangle? What do you see in terms of the angles? How do you see the angles comparing in terms of equilateral triangles? And then lastly, how do you see the angles comparing in terms of scalene triangles? On an equilateral triangle, 3 sides are congruent of a triangle, right? 3 angles are also congruent on the triangle. On an isosceles triangle, 2 sides are congruent, 2 angles are congruent. On a scalene triangle, 0 sides are congruent, and 0 angles are congruent. You see a comparison there? Okay, hopefully. Okay, on this, you can draw a right scalene triangle, where that, if you mark it clearly, just to be very clear as to what you're drawing, very explicit, very 100% accurate, you would have to mark the sides to demonstrate that they are not the same, just to specify that to the reader. Number 11, obtuse isosceles. Just that 2 sides are the same. With that obtuse angle, we can kind of just say, okay, look at it. Okay, for a right isosceles, it's a right triangle, so could these 2 sides be congruent? No. I can't mark it that way. If I marked it that way, it'd be totally wrong. Why do we know that that's totally wrong? What do we know about right triangles? A squared plus B squared equals. We know that about right triangles, Pythagorean Theorem, which implies that C has to be the largest side. C has to be larger than both A and B for that to hold true. The hypotenuse is the longest side, which leads right into this. You cannot have an equilateral right triangle. Okay? Because A squared, if it was an equilateral right triangle, A squared plus B squared equals C squared. That's like saying, okay, if A, B, and C are all the same, that's like saying C squared plus C squared equals, which is like saying 4 plus 4 equals 4. Not possible. None. No, not possible. Okay? This guy, what kind? It's a right triangle, but what kind? Isosceles, scalene, or equilateral? How do we know that it's scalene? That's a question. What's this angle right here? 30. Because, do you guys remember what the angles of a triangle add up to? Yeah. This guy, acute, equilateral. Okay, and then number 10. If you do it the way I do it, what would I do? I would read the question. I would read the whole question, get an understanding of the purpose of the question, right? Find the measures of the legs of an isosceles triangle. I would probably stop there as I'm dealing with it. That's the purpose. I already know the purpose. So I'm going to draw some triangle ABC as best as I can. I don't know which sides are congruent. Okay, all I know is that 2 sides are congruent, sure. And then I would label some sides, see if that gets me closer. I would draw the picture and I would label some stuff, see where I'm going. I would also, it says the perimeter is 34, fantastic, so the perimeter is 34. And then I would pause. Do I know anything about what the perimeter is? You would stop, what's the perimeter? How do you find the perimeter? That's the sum of the three sides of the triangle, right? So then I would say, do I know what the measure of AC is? Yeah, or AB, fantastic. Absolutely. Do I know what the measure of BC is? Yeah, 3x minus 1, fantastic. Do I know what the measure of AC is? X plus 1, fantastic. Now I have an equation, one equation with just one variable, and I can solve that. Ain't no thing. 6x plus 4 equals 34. And I can solve that, and I get x is 5. And then I need to always ask myself when I do something like this, did I answer the question? Have I fulfilled the purpose of this problem? No. Right? I haven't fulfilled the purpose. The purpose of this problem is to what? Is to find the angle or the side lengths. So I need to find these guys. So I need to backtrack again and ask myself a sub-question. What do I need to do? How do I find this? Well, they're all labeled with measurements, and I know what x is, so stick that in there. 14. 14. 6. Boom. Merry Christmas. Any questions? Oh, okay. Here's my explanation to you. This is why the sum of the interior angles of a triangle add up to 180. Not just because they do, but because of this case. If you rotate the figure, okay, if you reflect the figure and you just think about the angles themselves and you label them, that would be angle 3, that would be angle 2, this would be 2, that would be 3, 3, 2, 1, 2. And I'm going to only label a select set of them. And then you look at the angles in terms of straight lines or in terms of straight angles. What angles make up this straight angle? What angles make up that straight angle? 1, 2, and 3? All three of the interior angles of a triangle? Yes. What angles make up this straight angle?
2 and 3.
Nope. 1, 2, and 3. 1, 2, and 3. Right here. This little tiny guy. That makes up a straight angle, right? There's more straight angles in here. There's another. Here's another one. Oops, that disappeared. What makes up that straight angle? 1, 2, and 3. What's the measure of a straight angle?
180.
180. So why do 3 measures inside of a triangle add up to 180? That's the reason why. Because when you tessellate it, which is a weird word, add to 180. Okay, that's the takeaway. That's the part that you need to know. But the reason why, the thought process to get there is super important for you to be able to do. Super important for you to be able to follow those steps and read through it, okay? Okay, let's talk about this. So what do these 3 angles add up to?
180.
So x plus 80 plus 40 is 180? X is 60 degrees. So what do these 3 angles add up to? It's pretty sneaky texting on your phone like that. $108. X is 24. Go. Okay, on the next page, ladies and gentlemen. It's an equilateral triangle. We kind of made this comparison to the equilateral triangles at the beginning of class, right? We made the comparison that an equilateral triangle has 3 congruent sides, which means it has 3 congruent angles, and all of the angles are 60 degrees. The justification for it, an equilateral has 3 congruent sides, which means it has 3 congruent angles, and all the angles add up to 180. So you could do x plus x plus x if you wanted, which would be 3x equals 180. Or you could just show me that 180 over 3 equals 60. And you could say That equilateral triangle, 3 congruent sides, 3 congruent angles. Isosceles triangle, 2 congruent sides, 2 congruent angles. If that angle's 90, there's 90 left, so they're both 45. By the way, don't label the sides 45, because you're telling me the sides are 45 units. That doesn't make sense. We're talking about angles here, so actually label the angles. Put them up in the corners, or put an arrow to the corner. Same thing here. A is 34 degrees. Isosceles triangle. Yeah, it's from the description. Isosceles triangle. 2 congruent sides, 2 congruent angles. So what's left? We can mark these guys as x. So 2x plus 34 equals 180. And you get x is 73 degrees. So our answer to the question purpose is not x equals 73, because we don't care about x, because we added that in there so that we could do the problem. It was not in there originally. We just care that it's 73 degrees. Okay? On the next step, if we label them from the picture, figure out what x is, figure out what y is, figure out what z is. Okay? X, how are we going to determine what x is? If you notice on the top of the big triangle, there's a little triangle that's isosceles. If 2 of the sides are congruent, based on this information, if 2 of the sides are congruent, that means 2 of the angles are congruent. That means all of them add up to 180. So this guy right there is the same exact thing. So that's x. So 2x plus 28 equals 180. Minus 28, 152. Divide by 2, and you get, what do you get? 76? 76. How? Triangle sum theorem. That's not listed there. I probably should have. Nope. Triangle angle sum theorem. Triangle angle sum theorem. Okay. All right. So this guy, we know that that's 76, and this guy in the corner is 76. So I'm going to label him. Okay. How do we find out what y is? If you notice, I marked right here that there were 2 parallel lines. See the 2 parallel lines? You guys see that this is then a transversal, and y and 76 are corresponding angles. Corresponding angles. Angles are congruent, so it's 76. And then again, if you can see this on z, right there, you can see that that's a linear pair. Okay? So z and x add up. Z plus x add up to 180. X was 76. So z is 104. Linear pair. Okay? Go ahead and get to work on the rest. On this picture, if we want to solve it for x, notice how we're kind of transitioning from the angles to the sides now. Those measures are not in the angles, they're just written on the sides. But notice how the markings say that they're congruent. So that we can say 3x minus 2 equals 5x minus 14. Right?
Yeah.
We can solve that. We get 2x equals 12 and x is 6. So what we're looking. See, guys, do you see how it's a linear pair? They add up to 180 then, since that sucker's a linear pair. So simplify and solve, and we get x is 20. Okay? Let's go to the last page. There's actually 3 questions on the last page. If you do it the way I do it, if you work towards making a good pie, That angle's 48. This angle right here is 117. What's the measure of E? So I'll just drop in an X for fun. So if we drop in an X, that means all three of those angles add up to what number? 180. So 180 equals 48 plus 117 plus X. Solve that sucker and you can get X to be 15. So measure of angle E, no, that the question isn't what is the measure of X or what's the value of X. The question is what's the measure of angle E. So we need to state that as our final answer. The measure of angle E is 15 degrees. Since it's the measure of an angle, we need to say degrees. We can do the second question. The same triangle, we're kind of resetting the triangle. We're going to label, do it the way I do it, would be to label the picture. Understand what you're being asked for. You're being asked for what X is first. Okay, then you look at the triangle, those are angles. What do we know about the angles of a triangle? We know that they add up to 180, so we add them up. Say they equal to 180. And we solve it. We get 15x equals 180. X is then 12. And then measure of angle D we still need to do, so we take it and stick it in. And you get 50 degrees. It's got to be degrees because we're asked for an angle measure, not for a number. And the last question, if all the measures of the angles are the same, what type of triangle is it? Equilateral, right? Yeah. Peace.